So time to understand how ZKPs actually work. We'll cover this in three parts. First would be understanding key concepts. The second would be understanding the basic working mechanism behind ZKPs. And the last would be understanding some basic properties about ZKPs. So there are three main elements to ZKPs. The first is the prover. The prover is an entity that wants to prove the validity of a certain statement or that they have some kind of information. Then comes the verifier. Verifier is the entity that needs to be convinced of the validity of a statement without learning any additional information. And the last is zero knowledge. Zero knowledge simply means that no knowledge is transferred from the prover to the verifier beyond the fact that the statement is valid or the prover actually knows something. Now we'll try to understand the basic working mechanism behind ZKPs. The entire process works in 4 steps: initialization, proof generation, verification, and confirmation. In initialization, both the prover and the verifier agree on a common set of rules that defines how the proof verification would be conducted. There is also a problem statement, a statement that prover wants to prove that they know something without actually revealing it. Then comes proof generation. In proof generation, the prover creates a piece of evidence that is supposed to tell the verifier that they know something, but this piece of evidence is created in such a way that it doesn't communicate anything about the secret at all. Sometimes a blinding information is also added to this process so that the actual data can't be backtracked from the piece of evidence. The third step is verification. Here a verifier creates a challenge and sends it to the prover. This challenge can only be solved if the prover actually knows the thing that they claims that they know. The prover then prepares a response to this challenge using the piece of information that they know. Again, this response is created in such a way that the actual piece of information isn't revealed. At last, the verifier checks if the prover's response is consistent with someone who knows what the prover claims they know. This process might be repeated multiple times with different challenges just to increase confidence in the prover. Zero knowledge proofs generally have these basic properties: interactiveness, soundness and completeness, and non-transference. Traditional ZKPs are interactive, which involves multiple rounds of verifier sending challenges to the prover and the prover proving it. These interactions do not leak any information about the proof itself. ZKPs exhibit soundness and completeness. Soundness means if the prover is dishonest, they cannot convince the verifier of a false statement. Completeness means if the statement is true, an honest prover can always convince the honest verifier. The last property is non-transference, which simply means the proof cannot be transferred or reused by the verifier to convince another party.